Okay, well, I'm going to talk today about open source software. And the reason we're talking about open source software is that open source software is a lot of the projects in our lab involve open source software, both contributing and using. And so we're going to talk about why open source and how do we participate in open source software. But first, what is open source software? Someone to ask you, anyone have any ideas? What is open source software? You want to give a guess? Yes.
The source code is available to look at and edit for your own use.
Okay, yes. It's not commercially packaged or sold. That one may or may not apply, by the way, because some open software is actually commercially packaged, but it doesn't have to be. It doesn't have to be. Okay, let me give you a couple of definitions. Opensource.org. Open source software is software with source code that anyone can inspect, modify, and enhance. So the focus here is on what happens to the code itself. I'm not talking about the price, but anyone can inspect, modify, and enhance. That's one definition. Well, the Wikipedia definition, open source software, OSS, by the way, is a common phrase or acronym that's used, is computer software that's released under a license in which the copyright holder grants users the right to use, study, change, and distribute and source code to anyone and for any purpose. So there's actually a fair amount of debate on what open source software really is. There are even arguments, open source software. But this first one is the one I'm going to focus on primarily, is that the code itself is available for anybody to inspect, modify. Okay, what open source software has been successful? Have anybody used any open source software? Python is an open source software product. Any others? Linux?
Arduino.
Arduino, is that open source? Is it? I guess what I didn't know it was. I guess all the schematics and everything. Okay, what else? I'm going to list some. Libreoffice. Anybody heard of Libreoffice before? It's an open source office package that does spreadsheets and word processing, presentations, and a lot of people are using it. It's becoming more and more popular. Mozilla Firefox. Now, Firefox is actually it's a smaller part of the market now. I think there's only 5% of the browser market now. But it came out of the Netscape back when the internet and web browsing was new. They just put everything open source. But it's used a lot. I use it. What browsers do you use? And when I use Ubuntu, I use the Firefox one. That's a successful open source project. Gimp, has anybody used Gimp before or used Gimp?
Yes.
It's pretty powerful, actually. Gimp can do quite a bit. It's open source. GNU image manipulation program. Kind of like Photoshop, I guess, is sort of what it is, but it's an open source version. Linux. The whole Linux operating system is open source. That's a really amazing project, very, very successful. VS Code that we've learned about, that's open source. You should all know that. Vlc Media Player, has anyone used that one? I know they've got Windows and Mac. They've got a lot of ports for that one. Blender, anyone use Blender? Okay. The GNU compiler collection. GCC, does anybody use GCC? That's all open source. In fact, it was due to GCC that even Linux was able to be built. So that was a really key early one. Python, as someone already said. So a lot of great open source projects. Why do people make open source? Why not just sell it? What advantage do you get by doing all this work and just giving it away for free? What are the advantages of developing open source? Yes, Becky.
Well, can you basically get free labor because other people who want whatever you're working on are going to contribute, and it could be beneficial to you?
Okay, so if you want a project, you want someone to help your project, you can basically get free labor. Okay, that's one way. Yeah, you can get more people contributing to a project. Of course, they're going to want something out of it. They don't actually get free labor, but they're going to get something like maybe the benefits of the code you're developing too. So it's not just slaves working for free. You actually have people who are jointly working together to accomplish something of interest, common interest. Any other statement?
The tools will be really personalized goal, really specific.
They'll follow a community and what people want, sure. Any other ideas in why open source?
Really easy to fork off and create something else from existing code.
Okay, so starting point for creating your own projects. Dr. Nelson,
It turns out to be higher quality often.
why is that?
Thousands and thousands of pairs of eyes looking at it rather than 30 people in an industrial design team. There's no such.
Lots of people using and looking at it you can find. I'm going to cover a number of these specific, these are all great comments. They fall under a number of categories. Here's why, this is sort of from the opensource.org. Control. You have the control. If you have open source software, you can control it as you like. You can examine it, you can change it, adapt it any way that you like. If you have closed source, let's say you don't see this, you can't do anything with it. Can you change and recompile your Windows Word, MS Word to do what you want? No, you can't really do that. You don't have that control. This is an interesting one they said. By using open source software and participating in open source communities, you can become a much better programmer. Similar reasons why Dr. Nelson said why the code's better. You have a lot of people looking at what you did. And if you mess up, you learn really quickly that you shouldn't do that. So you get a lot of feedback, you get more critique. And so people that participate in open source projects are very good programmers because they have a lot more people helping and correcting you. Raise your hand. Have anybody here participated in open source projects before? Received heavily? There's a lot of, and when you make a mistake in an open source project, you hear it and you learn from your mistakes. So you get a lot of great training. You can learn to be a much better programmer by participating in open source projects. Security, open source software tends to be much more secure than closed source. This seems obvious, like, wait a minute, if it's closed source, can't you hide what it is you're supposed to do? And well, if everybody can see the bugs in there, we can fix them. And so there are a lot of closed source security projects that are really poor security because the programmers that wrote them think that it's right, but there's bugs, nobody sees it, and they carry on for years and years and years. But if it's open source, everybody can spot it and fix it. And most importantly, when there's an error, it can be updated very, very quickly. So a lot of people use open source software for security reasons alone. Stability. These projects last a long time. You'd think that a commercial project might last long, but these commercial software projects come and go. When you build a community around open source, they last a long time. You don't need one person. You have people coming and going all the time. These community users come and go, and they all contribute. And also, a lot of people like open source projects because you become a part of a community, like a community, like a group of people that join together to produce and promote software of interest. And so it's like a family almost. And you have personalities and people like that. They like to be part of a community. And so there's a lot of people who use it, and the open source software movement is growing rapidly. Now, there's also what's called the open source way. Open source applies beyond just software. And these are sort of these principles listed here can apply to areas outside of software, like transparency. In open source software, all the code is transparent. But it doesn't have to be software. It can be something else that's transparent. Collaboration. Anybody is free to participate. There's no rules on who is allowed to participate in an open source project, so long as you have the skill and the insight to participate appropriately in the community. This notion of release early and often is a principle of open source, where you're always fixing and releasing quickly. You don't wait until you get this big, massive release. You're always releasing. This way you can get rapid discoveries. There's this concept of inclusive meritocracy, meaning that good ideas come from everywhere, and the people who have the most to contribute are those who have the most credibility. It doesn't matter what your background is or what your degrees are. Who contributes the best ideas are those that have the most merit and credibility of the group. And then also a community. So there's a lot of, I don't know if anyone's heard of any of these. There's open source like blueprints, open source recipes, rules, hacks. A lot of these hacks that people share. There's a lot of good law, actually, a lot of law and government principles that people are like in open source legal codes, open source education. That's becoming really popular. And there's any other open source sort of things people are aware of outside of software?
Even open source hardware developments, I've seen open source VR libraries.
If there are, in fact, open source, I think of open source hardware almost the same as software. But in the end, it is, right? It's hardware pieces like Dr. Nelson was saying, isn't there open source like 3D printer models and stuff?
Trillions of design apparatus.
So there's all these things, there's this whole way of thinking. If you really get into the open source community, there's this what they call the open source way. These principles to make a better world, and it applies outside of software. We're going to focus on software here today. So I want to skip to a presentation and jump through a couple of slides. By the way, here's a book. There's a whole book here, Open Sources, Voices from the Open Source Revolution. It's an interesting history here. There's a lot of people that have made it possible. It's much bigger now than it was when I first started out. But Tim Ansel, he is an engineer at Google and has had a number of interesting talks that he's posted online. He has two of them. I'm going to only skip through a couple slides because he has a lot to say. But licensing, open source licensing is a big part of open source. I want to highlight a couple of things from his talk here. So what in his open source is code released under an open source license. We didn't really talk about licensing in my initial description, but the license is essential. The license is the legal arrangement at which the copyright owner can share the code. What is an open source license? Roughly, it's code that is freely usable, freely modifiable, and shareable. It permits you to distribute it, requires you to have the source code, allows you to do derived works, and allows any people, group, or endeavor to participate. There's a lot of discussion on open source licenses. I'm going to skip over a lot of his because we don't have time. But there are many licenses you can choose from. And he groups the licenses into two types, what's called permissive license. And he says this one is do whatever you want with the code. This comes with no warranty, sometimes requires attribution and no requirement to contribute. This means that if you find bugs, you don't have to submit them back there. You can do whatever. It's very permissive. You can do whatever you want. I don't care. You can change it on your own, so forth.
Mike, what does attribution mean? You want to find that?
Attribution is where you say where the code came from. So like, if I use a library in my code, some licenses require you to attribute and say that you're using that code. And there's lots of different variations here. And as we'll talk about, you need to follow the license, right? We have to follow the license there. There's another, here are common permissive licenses. There's like the BSD, like MIT licenses, Apache, Creative Commons licenses here. There's lots of what's nice is that there's lots of licenses out there that you don't have to create them yourself. In fact, as Tim would say, you don't ever want to make your own license. Never make your own open source license. Always use one of the ones that are out there. There's another style called share alike. This is where you must share your changes. So it still doesn't come any warranty, but if you distribute the code and you change it, you have to share your changes back with the community. So let's say you find a bug and you fix it and you distribute that bug. Well, you have to make sure that that bug you fixed is actually pushed back up to the repository so everybody gets the benefit of that bug. So the social contract here is I let you use this if you let me get your changes. And the reason we do this is we want the best code. If people are finding bugs, you want it to come back into the community so that it's a better solution. Okay. One thing I just want to say here, there's all these different the share alike. There's GPL version 2, GPL version 3, Creative Commons BYSA. There's lots of different licenses out here. Just never create your own license. I love his slides. Then he highlights never create your own license. Never create your own license. And the reason he says that these licenses are lawyers and many people spend many millions of dollars debating and legal fights over these licenses. You want to use something that has been tried and true by a lot of people. So you can never use your own license. Okay. Open source software and you. I'm going to discuss a couple of different ways in which you may be interacting with open source. And we talk about what your responsibility and your role is with open source. So first, all of you are passive users of open source software, okay? That means you use open source software. Most of the time, you don't even know it. Linux, a lot of the internet protocols that are used are all based on open standards and open software. You don't even know that, like various protocol clients and whatnot. And in this case, as a passive user, you don't even look at the code. You just use the code. You can look at the Linux source code if you want, but most people don't. I don't know what percentage of Linux users actually download the code to look at, but most don't. So a passive user. Now, you can be an active user. This is someone who takes the code. You actually look at the code and are aware of the code, and you integrate perhaps the code into a project of your own. So you're a user of the code. Anyone here used open source software in this active user mode before? Actually, a couple of you have actually downloaded and looked at the code. Okay, good. Another mode of operation is be contributor. You can follow, this is where you actually follow active updates of the project, and you're actually contributing to the project. You're making changes to the project, you're adding code, you're adding bugs, maybe you're adding documentation. And then finally, you can be the owner or the manager. You can create your own open source repository and build your own community of users and contributors. Has anyone here ever created their own public open source? All right. What project was yours, Dr. Lloyd?
It was Logic and Memory Emulator. Was the most recent one.
Okay.
Oh, actually, a more recent one was the floating point compression and hardware. So that's a hardware example where it's source code, but it describes hardware.
Okay. As you, in our labs, many of you will participate in open source projects. Let's talk about each one of these. Now, as a user, what is your responsibility as a user of open source software? Well, the main thing is you have to adhere to the license. You should, if you're using or looking at the code, you should follow the rules of the license. So can you think of an example of a way you would violate the license? Can anyone think of a, yes?
Saying it's your own and then selling it.
Okay, for example, claiming it's your own when it's not, that would be a violation of the license, okay? That you wrote the code. What else? Any others? Jacob?
Essentially forking it and then closing it.
Well, you can fork your license. When you say closing, what do you mean?
Like taking the code and then closing it off.
If the license doesn't allow you to do that, some licenses may allow you to do that. Okay, but if there's one that doesn't want you, like then you can't do that. Like, or for example, let's say you change the code and you make a product and you sell your product and you didn't take those changes and put it back in the open source, then that is a violation. Dr. Nelson.
That's been the subject of lawsuits.
Yeah, there's big lawsuits, and there's lots of, and in the ethics, we talk about ethics. We had our deep dive on ethics. We don't violate the license. That you just don't do that. Some people try to get away with it. And you notice a lot of software, you actually have to click the boxes, like I know in Vivado. We use Vivado, and they have the GNU C compiler embedded inside it. And anyone know what happens to happen? We have to click a box saying that they have to let us know that they're using GNU C compiler. And that's part of the way you check a box. So you have to do that. If you distribute GCC, you need to do something like that as well. Okay. As a contributor, we're going to talk about a contributor. Most of my discussion today is going to be what you need to do as a contributor of a open source project. And then we'll talk a little bit about what it means to create your own open source project. But for here, let's just say you have to follow license. There's lots of interesting legal, and just don't break the licenses. It'll hurt BYU, it'll hurt you. You need to follow license. Okay, first of all, an open source project is actually a community, kind of like a ward or a neighborhood. there are people that work together. Now, what happens when you get people together working on something? You think of kinds of social things that happen if we work on something together. Make friends. Yes, you make friends when you work with people. That's a big benefit of open source communities. You make friends from all over. We would have a project. We have friends in our. Dr. Nelson, where are the friends in your projects you work on? Where are they? Are they here in Provo?
Oh, they're all over the world. Interesting people from interesting places.
All over the world, in all time zones. We just communicate people all over the world. Okay. What other things happen when you have communities of people working together? Let's say like your warders can get together and do a big service project. Yes.
Make enemies.
You make enemies. Absolutely. You make enemies. You step on people's toes. You know, when you work together, sometimes so communities, and what can happen to communities? Poor communities. Poor communities could just fall apart. You know, bad actors. And so in order for an open source project to be successful, they need rules to facilitate productive interaction. So rules like who decides what gets done, or oftentimes you have people debating, no, the code should be written this way. No, the code should be written that way. There's bitter disputes. And who decides who wins? Well, that's something that the open source community must resolve. So you have to resolve differences. There are rules in how you have to treat people. It's unfortunate, but in some communities, like online communities, what happens in online communities? Have you ever heard about some of the real negative effects of there's some really poor online communities where people are treated very poorly. In particular, there's a lot of harassment, especially among women. I don't know if you've heard about like these gaming communities. Just really, really bad actions of people treating people poorly. And so you don't want that. An open source project's not going to work well. So there's rules on how you treat each other. There's also rules on how to format, test, and contribute to your code. So oftentimes when you're participating in a project, there are codes of conduct. Because when you work together, we never always just work. We never have problems. There's always conflict or differences of opinion. And so these codes of conduct provide rules to facilitate a positive environment and reduce the conflict that will hurt people and the project. So the kinds of things that are unacceptable behavior, harassment and bullying of any kind, personal or political attacks, sharing of private information. So for example, if someone puts your name, a lot of times these people don't share their names in some of these projects. And a lot of times they just use their GitHub username or whatnot. In fact, this one project, people refer to each other. They don't call them by names, they call them by, GitHub user IDs is what people often do. So in order to participate in an open source project, you often need to agree to abide by these codes of conduct. There's not like a government out there that tells you how to live in an open source. It's sort of open, and so bad things can happen. I've heard some pretty bad things happening in various communities. And so I want to just show you an example of a code of conduct here. This is one, it's the contributorcovenant.org. I'll just read this opening pledge. In the interest of fostering an open and welcoming environment, we as contributors and maintainers pledge to make participation in our project and our community a harassment-free experience for everyone, regardless of age, body size, disability, ethnicity, sex characteristics, gender identity and expression, levels of experience, education, socioeconomic status, nationality, personal appearance, race, religion, or sexual identity and orientation. So if you participate in a project that follows this pledge, then you can be kicked out essentially if you don't abide by them. There's some people just violate these. They'll for example, the use of sexualized language or imagery and unwelcome sexual attention advances, trolling, insulting, derogatory comments, harassment, and so on. So the owner of an open source project wants to make sure everyone feels safe and they'll follow by, and often as a contributor you need to abide by this conduct. Has anybody ever been aware of people not following codes of conduct and maybe difficulty? I don't know, maybe you haven't been involved. Did you say you had a lot of times people are just kind of mean too. That's just, they're kind of a jerk. I don't know how to say it, but they're not, but we disagree and we can work through it, but there are some behaviors that are just not tolerated. Now, by participating in an open source project, you work with open source. How do you manage who gets to decide how the source is changing? Can anybody just get in there and just change the code whenever they want? Do you think Linux could be built if anybody just went in and just do whatever they want? Jacob.
It probably work like how we do it in GitHub or, I guess it's pull request, but it probably works the same way, right?
It does work the same way. We have to be very careful how we make changes. We want to make it easy for people to make changes, but we don't want to make it easy for them to just break our system. So careful control of the software source is essential. You want to prevent unauthorized editing. You want to enforce coding standards. You want to test, integrate improvements, and have a very careful way of doing version releases. And so something like Git, we teach you Git in this. I think Git, was that our very first thing, Jeff, in boot camp? Git is one of the most successful tools for managing this here. And you must be proficient in a version control software like Git.
Is Git open source?
Is Git open source itself? I would suspect it is. Jeff, do you know that?
Well, I'm sure it is.
I'd be surprised if it's not. It's possible, but I suspect it. I'd be very surprised if it's not. And so you need to have a very good understanding and skill in these tools. If you want to participate in open source software, what does it say there?
Git's github.com/git/git.
Oh,
It's hosted on GitHub. So if you don't know, the guy who made Linux is also hosted on GitHub. And the guy who made Linux also invented Git. So
and there were lots of older, other revision control systems. Like I used SVN, CVS over the years, and they weren't quite as good. And so Git is a very interesting model that's quite innovative that it is very easy. So you need to be conversant. They're hard. You learn about branching, you learn about pull requests and all this stuff. I actually introduced Git in my 323 class. A couple of you took my class, and you smile back there and all the challenges you face. What I didn't do is teach you properly, but I can say it's an essential skill. And if you want to participate in open source projects, you need to become proficient. If not Git, whatever the tool is. So, and you need to follow the rules, and they'll enforce them. So a good project won't let you break their tool, and they'll prevent you from doing that. But you need to follow their rules. Dr. Nelson.
You gonna talk about CI at all?
A little bit, not a lot. I am going to talk about CI. It's coming up. So there's different roles in the source control. We're mostly going to be contributors. Okay, contributors. That's where we create comments. We submit pull requests. What they call triage, where we can review issues and so forth. Our role is to essentially improve the software, improve the issues of documentation. And then there's the committer. They call it the committer. These are people that have commit access. They actually then commit into the repository. Most of our own private repositories, we commit. We don't think anything of it. But in a big project, you never commit to big projects. Instead, what do you do instead of committing? Submit pull requests. And then the committer will accept them, comment them, or reject them. And you often have your pull request rejected because you did something wrong. So coding styles. Many projects have requirements on the style of your code, how you document it, how your comments are written, your formatting, your line spacing, all these rules. They're kind of annoying, but it's important because they want the code to all follow a certain style. And there's a lot of styles that are published. One is like PyLint for Python. We have a module in here on PyLint coding stuff. What others are there? Like C. Can you think of other coding styles? There's whole bunches of these. There's different styles where you have to code. And static analysis can be performed in code. So there's a program that will run in your code and it'll tell you that your code is not formatted properly, and it'll reject your pull request. I think, doesn't CS 235 use it'll reject your code? Don't they use style checks? Anyone know? They use Valgrind for memory leaks, but they don't do a style check on it, or do U330 use a style check?
yeah, kind of.
For grading, I guess, right? For more grading than actually checking.
Yeah. I mean, there's a coding standard that we have for 330. So
So Dr. Lundergan mentioned on Friday, Python, he says you just use a formatter, like the black formatter. And if you're using a formatter, then that usually solves the problem. The problem is you have to make sure your formatter and the format that the project is using is the same. I've never actually, it's configured the same. Otherwise, every time you commit, each of you are formatted differently. So this is where Dr. Nelson was referring to. In large projects, there's a lot of code testing and what we call continuous integration. We're going to talk, this is a module, Friday's module, I believe, is on unit testing and continuous integration. Most repositories perform tests to make sure the code does not introduce any new problems. So we want to do this to prevent bugs from being inserted and whatnot. And so as be a participant, you need to be aware of their testing procedure and test your code before submitting any pull requests. And we'll discuss this more on Friday. So there's a lot involved, isn't there, to contribute, isn't it? It's not that easy. You don't just go in and just start hacking code. We have to follow all these rules. In addition, many projects require you to certify the origin of the cert. They want you to declare legally by signing your commit that you declare the authenticity of work, that you created the code. The reason they want to do that is they want to avoid problems that occur in an open source project. What do you do if a contributor copies some code from a competitor, steals it, and then commits it into this open source repository? Is that ethical, first of all? No, it's not ethical. But the open source project now is going to be tainted by this stolen code. So it's hard with open source because people are contributing code. How do they know where the source of the code came from? So by requiring the contributors to sign, then the project itself is not legally liable. You are, because you said legally that you said this was your code, but you actually stole it. And so then of course, the project would remove that code, but it puts you in legal jeopardy to steal code and then say that it's yours. So, and there's many ways of doing these. They call these developer certification of origin. And you can actually sign the code as a part of your commit. As part of the commit, you have a little signature that says that you certify that your changes are your own. Yes?
That'd be a little bit different of a discussion, but how different does code need to be for it to not be plagiarized? We kind of talk about this in like academic settings, but in business setting, the code does the same thing, but does it differently.
Boy, that's a legal arrangement. Dr. Nelson has probably more legal. Could you want to comment on that? It's the courts decide this sort of thing, by the way. What happened? A very common kind of legal case is an employee of one company leaves, goes to another employee, does take the code, but changes it some amount, and then the courts have to decide, was that copied or is it created from scratch? Let's put it this way. If you're not legally allowed to copy code, don't ever take code that you shouldn't take, okay? I mean, if you are at a company and it is proprietary, it is illegal for you to take that after you. You need to destroy it or leave it on the computer there. So don't ever ask that question. Don't get in a position where you have to ask the question like, ooh, I copied all this code. I need to change it enough. Well, it still works, but so that it legally would be different code. You never want to be in that position. Okay? You want to start with clearly legal open source code with a license and work from there. Okay. Here's an example of a certificate, a developer certificate of origin. By making a contribution to this project, I certify that the contribution was created in whole or part by me, and I have the right to submit it under the open source license indicated in the title, or it's based on previous work that, to the best of my knowledge, is covered under appropriate open source license. And I have the right under that license to submit work with modification, and the contribution provided directly to me by some other person who certified A, B, and C. Anyway, so this is a sign. This is a legal agreement, actually, that you're signing when you participate in these projects. A lot of people and students kind of take this stuff for granted. You ignore whose code, you just sort of make code, copy it. Well, in the open source world, we need to be careful. We need to make sure that the sources are correct. I want to go back to one of Tim's presentations and talk about some of his slides. Best practices. Sorry. So what are some good practices in participating? Open source best practices. If you are a contributor to a project, here are some best practices. One, I'm not, oh, he says, if you screw up, admit it and fix it. You know, it's community, you make mistakes. You know, people forget to do their assignment or whatever. You know, you lose credibility, but, you know, admit it and go on. Know the existing community. So when you don't just go in and sort of hack away, get to know, listen to the issues, get to know the people, and slowly work your way in. Don't just dive in. It's kind of like going into a new culture and just telling everyone how to do it like the way we do it back home. That doesn't work well. You need to learn the community. Every community has different standards. They have different source standards. They have different coding standards, different testing standards. And so to participate in community involves some time to get to know that community. Many of you who served and went overseas had to learn that they do things differently in other places. And so you get to know that community and appreciate it so that you can contribute to that community. Here's another, let me look at some other reasons for, okay. There's this open source guide. Open source guide has some really great lists, how to contribute. There's many ways to contribute here. You can, if you go through this, why contribute? I'm not going to go through and read it. What it means to contribute. You don't even have to, there's lots of things you can do without even contributing code. There's orienting yourself to a new project, getting to know the community, finding a project to contribute to, how to submit a contribution, and that's involved. Once you've done it, then you get to go better and better, you move faster. And what happens after you submit it? Congratulations, you know, what happens next? Then people accept it and include it, you did it. And it's pretty satisfying when you contribute to a project and that contribution is actually integrated into the open source project. I thought one of the activities could be provide a real contribution that is accepted by a community. Well, that takes a long time. That would take you too long to be, so I didn't ask you to do that. So here are kinds of things you can do as a contributor. Find an open source project of interest and read about it. Its goals, its visions, rules, and learn how to be a contributor in that community. Clone and build a project. That's pretty easy to do. Just check it out, clone it and build it, see if you can get it to work. You can suggest improvements for the documentation. You can actually contribute documentation. Most people really like contributions and documentation. Dr. Nelson.
A lot of these projects, the developers are so into it. You come in as a new attempting to use it, and you read the documentation and go, ah, who are they talking about? They love it. And don't suggest their documentation isn't good. Just start changing their documentation and contribute changes. And they will recognize, this is a new user. This is what they didn't get. And we are having a lot of success with that here in our group.
So just that, and they love it. They really appreciate that. And that's a great way to get to know it's like maybe if there's spelling error, or you can do but even more, say, I want to give a better example. It's very easy, and the bar to accept changes in documentation is a lot lower than code. It's hard to break the project by changing the documentation. Of course, you know, I don't know, there's probably malevolent users who submit, you know, profanity or stuff like that. There's probably checks for stuff like that. But for the most part, most reasonable document changes are going to be accepted. Depending on the community, I don't know what, you know, it's harder to automatically check documentation, but usually they'll look at, oh, that looks interesting, and they'll accept it. You can submit issues. What is an issue? Anyone know what an issue is as a noun? What is, yes?
Something that could possibly be a problem.
Yeah, in the GitHub repository, yeah, it's a potential problem. They have a whole database for tracking issues, and you could submit an issue, which is a bug report, for example. Bug report might be another name for issue, but it's not always bug reports. It's like, it's an issue. It could be a documentation problem, and so if you find something that's a real issue, you can submit it, and then there's a whole chain of comments that go on that issue. So that's another way you can contribute. Make small changes and submit a pull request. That's starting to get that's a big step for someone to actually accept your change, but that's done. The more you get involved, you participate in chat discussion groups, become acquainted, and eventually you work yourself up to becoming a regular contributor. So there's lots of ways you could contribute, and we hope that many of you will participate as a contributor in open source projects. Several of our projects are, those of us in our SymbiFlow classroom group, you guys are actively, many of you are going to participate in other projects that as contributors. So any questions on being a contributor? Does it make you excited to be a contributor? Do you know that to be a contributor, you don't have to be a graduate, you don't have to have a degree. This is a meritocracy, which means that if you have the skill to contribute, they will accept you. You do not have to have a degree or certification to contribute to open source. It's all your skill and what you have to offer. And so all of you should have enough skill to contribute to open source projects this summer by participating. Okay. So here, for this module, here are the activities I'm going to ask you to do to complete credit for this one. One, I want you to identify at least 3 open source projects of interest that are related to your summer research or that are personal interest. So find them, search it, go find them. There's a bazillion open source projects out there, by the way. So this should be a very easy thing to do. Try to find one that's closely related to your project. 2, learn about each of the following for the 3 projects you select. First, determine the license of the project. I'd like you to go through and actually find, it's not that hard. If it's a GitHub project, the license, there's a link to it on the front page, and you can find the license very quickly. 2, identify the contributor code of conduct and just look it over. 3, try to figure out what's involved in contributing to a project. This is a little harder. It doesn't always say up front, but if you poke around a little bit, you'll probably find a contributor's file that'll tell you what that is. So do those 3 things. And then for one of the projects, what I call the project deep dive, take one of the projects and clone it, review the commit activity of the project, and review some issues of the project. So this isn't that involved. I don't know if Dr. Nelson or Dr. Goders have any, Dr. Lloyd have any ideas for more activities, but this is a way to just kind of introduce you to open source software and what's out there. I don't think requiring you to accept, make a change in a project is always, takes time because they often have to look at it, but many of you will be making those. Okay. All right, any questions about becoming a contributor to an open source project? All right, let's move on to the next step. Creating your own open source project. Some of you did. Dr. Lloyd said he created one. Do you think you could create your own open source project? Do you have anything you want to contribute? It doesn't take much. We're going to talk about what it means to create your own open source project. So here are some 4 simple steps you can do to create your own project. 1, create a public Git repository. It doesn't cost anything. You do need to choose an appropriate license. As Tim said in his slides, if you don't have a license, it's not an open source project. So choose a site license, create a project README, and then start adding your code. The bar is pretty low in creating an open source project. I want to go back to Tim's slides. Number 2, a lot of good stuff here. He's one who thinks that basically you should, first of all, by the caution before you create your own repository. Before you create your own repository, make sure nobody has already created an open source project of the same thing. So contribute over create. So before you create, it's better to contribute to something that exists. So it's better to contribute upstream because upstream there are free people maintaining. If there's something you need done, rather than starting from scratch, why not go out there and see if you can find someone and then contribute? Yes?
What does upstream mean?
Like the repository upstream in the cloud. So there's other people upstream that you could contribute. Think of that as the repository that you're contributing to. Rather than you going downstream. You create stuff and it goes downstream and people use what you've done. Consider instead going upstream and helping others in something they've already started. So in the short term, it is harder to contribute. The bar to contribute is a little higher than starting your own project. It's very easy. In 5 minutes, you could create your own repository with license and everything. But it probably takes you a few weeks to really contribute. So, but creating a project is really a long-term commitment. And you don't want to do it unless you have that long-term commitment. So ask yourself, will the project continue with no funding? because creating a community is hard. And there are a lot of guides on how you can do that, but it is hard. Let's talk about let's say you do decide that you can create your own after all. There are tools used. Use Git. Use Git. It's a revision control system as well. There's a lot of people use it and a lot of contributions. I'm going to skip over. There's a lot of details here on different documentation, repository naming, the links there you can read on your own. The repository needs to contain a license file. Remember that the code has to be released and you need a license in order for it to be considered open source. So do those and pick a license of your interest. Don't contain source code, not binaries. Yes.
Do you have any comments on, is it important to put the license at the top of every?
He does have
file?
some, I skipped over some of that. He has some opinions on how you do with the license of the files. So I can go back there. We're running a little bit of time, but I can find it. Where did he say? It'll take me more time to find it. He does have that. You might have to have a license. I'm going to skip over all the directory here. Oh, he does say open source header file. He recommends a header file here. And then the authors listed in a contributors file. Never remove someone's copyright header. You can change, you can add to it, but don't ever remove it. Okay. Here's what he thinks the minimum is: a README file, a code of conduct file, and a contributing file that explains the overall of the project, the code of conduct, and how you contribute to the project. I'm going to skip over some of all these details. Okay. And be careful with combining stuff. Sorry. Do not do these, he says. Do not create your own license. Do not use a license that is not detected by GitHub. GitHub actually can detect the license, by the way. And if you can't detect it, don't use it. Don't change the code license. Don't remove copyright headers. Don't reformat code. You got to do this carefully. This is where if you reformat your code, all of a sudden you have all these new commits. And don't fork a project, but this idea of GitHub forking is different. We talked about GitHub forking already, I believe. Okay. And release, or he said, release early, release often. What that means is just continue to do lots of releases. Don't wait until everything is perfect. Of course, you want to pass your tests and everything, but it's better to give the community the code quickly so that everyone gets all the benefits. If there's a problem, quickly fix it. Okay. Release before you think it's ready. Code is always bad. Don't wait for it to be perfect. Use time-based releases and always be ready to release. Focusing on community. Would your project survive if DARPA cut the funding? Well, if whoever's funding you stopped funding you, would the project continue? That's hard. Especially we have a number of university projects and the projects come and go. We keep it going. So you need to build people, you need users, and you need to avoid toxic people. I'm going to skip over. So I'm going to skip back to the presentation here. So things you need to think of if you do decide to create your own project: how to start it, how do you find users, what are the best practices for maintainers. It's hard to maintain a good project. It takes a lot of time. What kind of leadership and governance, code of conducts, and the legal side. Okay, I want to show you a open source. There's a great guide here, opensource.guide. Whoops. Source.org/guide. If you really want to, not guide, source.guide. There's a really good reference here on the things you need to do to maintain a repository. How to contribute, there's a whole chapter. How to start a project. Building communities, how do you build welcoming communities, involve everybody. Finding users. Best practices for maintainers, leadership and governance of ideas, codes of conducts, ways to get paid for open source. A lot of people make a lot of money on open source. How do you make money on open source projects? Any ideas? What's that?
I mean, someone who wants funding,
Funding, who's gonna fund you to do open source?
like, I think, some big companies fund like, Python. So
Okay, so they donate to the project, and there are nonprofit organizations that can do that. There are companies that support software. There's a number, I know a number of my students have recently joined companies where this company works very hard on an open source project, but they actually provide support for companies to use it. And they make pretty good money doing that. Red Hat's kind of an example, they make money by supporting open source software. There's lots of different models. This Enjoy Digital group, which is a pretty amazing group, they provide a lot of hardware services, but they provide a tremendous amount of hardware, FPGA logic IP for free, but they make their money by building end products for people, consulting and whatnot. Yes?
For example, like, Plagiarized, Google's primary motivation for funding.
Well, I mean, there's companies like Google that fund people to contribute to open source. In fact, they have a lot. They fund probably most of the money they spend is on their own employees and others to work on it and trying to build users. But they want to use software that is open source that lots of people are looking at. So they're trying to build an open source hardware community, something they're actively investing in to try to build to have all the advantage of open source. Most hardware. Software used in hardware design is closed proprietary source, and they're hoping to build communities of people that provide open source so that it's more secure, more control, all of those benefits that we talked about.
What is the end goal of SimFlow to create an environment similar to Vivado, or?
Well, I mean, first of all, they've renamed it. It's not SimiFlow anymore. It's called F4 FPGA. They want to develop tools that. Not like Vivado per se, but just an open set of tools where people can create hardware development platforms that are customized their own way. I suspect they want to do that internally. They want to have custom hardware description flows, and so they have all those benefits. Yeah, I suspect they would like to customize it, but there's not a strong, or at least it hasn't been strong open source hardware communities yet for them to do that. So they're trying to seed the community, and I can't speak for them. Tim Ansel has a lot of presentations online you can watch. But that's my sense here. Dr. Nelson, do you have anything to add on their motivation?
There are, I mean, as I've talked to them for them, they seem to not want to be limited to any closed tools. So the big proponents, of C and LLVM, et cetera. And I don't know if that's a corporate philosophy, whether they're just a group of people who have that. But for example, the example that he shared with me, he said, well, we have these big build systems and they're not based on a GUI running on a single workstation. Okay, so can you see that a tool which was designed for a single person to sit in front of a workstation is going to work in an environment where they're building and deploying across the world using all these automated, make and other similar kinds of tools? I think there's a certain amount of that going into that as well, because it's a very different model.
Yes, yeah. I think and there's actually growing interest in it, by the way. There's open source ASIC design tools that are quite impressive. So I think there's a lot of different motivations, and it'll be interesting to see how these open source for hardware design. Yes, Dr. Nelson.
So when I first learned about open source, my mind, my mental model of this open source was just a bunch of people who were contributing to something, but without a real leader. That is not the case. Linux is the great example. I mean, the originator of Linux, which is, how do you say his name, Linus?
Yeah. Mm-hmm.
Yeah, okay. I mean, exercises very strong control about directions and what gets included, et cetera. And I think most open source projects that are successful, they do have a central core leadership. Right? So this isn't just a whole bunches of unaffiliated people, nobody in charge that somehow magically this wonderful tool is being developed.
That's right. In fact, I had a student who once wanted to contribute to the Linux kernel, and they have all these tests you have to pass. And they get hard, they're like puzzles. And, and you have to like download the kernel and you got to do something to it. And he got pretty close actually to getting there. And I don't know if he ever actually made it all the way. But but once you can do that and you have the skill, they want you, but you gotta develop that skill. I was surprised how involved it was. And they have to have other people review your change to approve it. And then later you have to become a reviewer before you can actually be qualified to make changes to the kernel. So one thing about, we're talking about Google. Google is a sponsor of our boot camp. They are providing us funds to help us train you. And the reason they are interested in doing it, they want us to help train people like you to have the skills necessary to contribute to open source projects. And if you complete the boot camp, you will have tremendous skill to contribute to open source projects. And so they're supporting us in the creation of this boot camp, and they're hoping that you will participate in these projects here. So Dr. Lundergan just walked in here. How many open source projects do you work in your lab? How many, on top of your head, how can you think of? And then how many open source projects do you actually use? Ton.
Uncountable. I mean, we use tons of software.
So in his work with networking relies really, his community in networking has a lot more open source than I think our hardware community does. We're kind of working towards it here, but everything, I think the internet itself runs on open source too, is my understanding, right? And so their group does a lot. So we're hoping that all of you then can participate in open source. Just in summary, open source software provides a significant amount of the software used today in all areas of computing. So it's ubiquitous. Open source helps build important technical communities and increases the pace of innovation. Open source requires dedicated contributors like you to help improve and expand our computing infrastructure. And participating does require skill, cooperation, time. And it's my pitch that all of you will consider becoming contributors in open source software. So any other questions? And that just ends our discussion. So if we have any other comments or questions, we can go from there. You see a hand? No. All right, well, thanks for participating. So in order to complete this module, go through and do those activities. If anyone has any ideas and some other activities that we could ask you to do in the future. This is the first time we've done this open source software module in the hopes to get you more involved, but we hope to make this something part of our group. All right, thanks everyone.